In the last video, we talked about polar coordinates and we plotted polar coordinates on a polar coordinate system. In this video, I want to talk about the relationship between polar coordinates and the rectangular coordinates that we're all familiar with. So if we start with the rectangular coordinate, let's say we have a point P equal to x comma y. So we understand that to mean that in order to get to P, we have to go over x on the x-axis and then up y on the y-axis. So if we draw a line from P to the origin and we call the distance r and this angle between them theta, then we can also think of P as a polar coordinate written as r theta. And so what I want to do is explore some of these relationships that we see. So what do we see? The first is that if we use the Pythagorean theorem, we get that r squared is equal to x squared plus y squared. And then what else do we see? So that's going to tell us that r is equal to the square root of x squared plus y squared. So if we were given, something in rectangular coordinates, we could determine r just by knowing the points x and y. What else do we know? Well, if we look at this angle theta, we know that the sine of theta is going to equal y over r. And if we solve for y, we get that y is equal to r sine of theta. Similarly, we get that the cosine of theta is equal to x over r. So then we get that x is equal to r cosine theta. So if we are given something in polar form, and we know r and we know theta, we can determine x and y completely just from that information. Next, we see that the tangent of theta is equal to y over x. So that means that the tangent inverse of theta, the tangent inverse of x over y is going to equal theta. And I said x over y, that I meant y over x. So we have that if we're given y over x, we can determine this angle theta. And similarly, we could figure out r, and then vice versa. If we are given theta and r, we can determine x and we can determine y. So why is this important? It's important because now if we're given something as a polar coordinate, we can rewrite it as a rectangular coordinate and vice versa by using these relationships. One thing to note, and this is also given in your book, is that the signs of x and y in rectangular coordinate form, they determine the quadrant for our angle theta. And so we usually choose theta so that it's in between negative pi and positive pi. So for the rest of the video, I want to just kind of do some examples of how we can go from polar coordinates to rectangular coordinates and vice versa. So first example here, we're given something in polar form and we want to change it to rectangular coordinates. So we have r is 8 and theta is pi over 3. So what do we know? From the diagram in the last picture, we have that x is equal to r cosine of theta and y is equal to r sine of theta. So we can determine x and y completely just by knowing r and theta. So all we're going to do is just simplify into these equations. So we get x is equal to 8 times the cosine of pi over 3. So we get that x is equal to 8 times the 1/2. And we get 8 is equal to 4. X is equal to 4. Now, similarly, we get that y is equal to 8 times the sine of pi over 3. So we get y is equal to 8 times the square root of 3 over 2. Think of 8 as being over 1, so we get 8 radical 3 over 2. And then if we cancel, simplify, we get that y is equal to 4 radical 3. So if we are writing this polar coordinate into rectangular coordinate, we get that a is equal to 4 radical 3. Let's look at another example. Here we want to change the point B equals -2, -5 pi over 6 to rectangular coordinates. So how do we do that? Well, we once again remember the relationship between x and y and r and theta. We have that x is equal to r cosine of theta and y is equal to r sine of theta. So if we substitute into this equation, we get that x is equal to -2 cosine of negative 5 pi over 6. If we draw a picture to kind of give us a sense visually of where we're at, negative 5 pi over 6 is going to be right here. And so we are going to have a cosine there of negative square root of 3 over 2. And so if we simplify, we're going to get a positive root 3. Now, if we're looking at what y is equal to, that's going to be negative 2 times the sine of negative 5 pi over 6. And that's going to be negative 2 times negative 1/2. And that's just going to be a positive 1. So if we're writing the point B as a rectangular coordinate, we get that B is equal to the square root of 3, or 1. All right, so next we want to start with something in polar form. We want to start with something in rectangular form and change it to polar form with these given conditions. So what do we know? We know that if we have r, that's going to be equal to x squared plus y squared. So that's how we relate the points x, y to r. Now, how do we relate them to theta? We remember that the tangent of theta is going to be equal to y over x. So let's start by finding r. If we know that r squared equals x squared plus y squared, here that's going to be square root of 3 squared plus 1 squared. That's going to be 3 plus 1 is going to be 4. So we get that r is equal to 2. Now we have that the tangent of theta is equal to 1 over the square root of 3. And so that means that theta equals the tangent inverse of 1 over root 3. And so theta is going to equal 30 degrees, or pi over 6. Now, if you don't believe me, just to confirm, we've got the sine of pi over 6 is equal to 1/2. We've got the cosine of pi over 6 is equal to the square root of 3 over 2. So the tangent of pi over 6 is going to be equal to 1 over 2 times 2 over root 3, because when we're dividing by a fraction, we multiply by the reciprocal, and that is indeed 1 over radical 3. So we're good. So altogether, this means that if we are writing the point C as a rectangular coordinate instead of a polar coordinate, we get that C is equal to 2 pi over 6. Now for our last example, we once again want to change this rectangular coordinate to a polar coordinate. So we start out with our relationships that we need to relate x and y to r. We have that r squared equals x squared plus y squared. And to relate x and y to theta, we have that the tangent of theta equals y over x. Now, just substituting what we know that r squared equals 25 squared plus 0 squared. So we get that r squared equals 25 squared. Now, if r squared equals 25 squared, then r is just going to be 25. Now, if we're trying to determine theta, we've got that the tangent of theta is equal to 0 over 25. Well, that's just going to be the tangent of theta equals 0. So theta is going to equal the tangent inverse of 0. And that's just going to be 0. So this tells us that if we are writing the point D equals 25, 0 from a rectangular coordinate as a polar coordinate, then we get that D is equal to 25, 0. And so in this case, the rectangular coordinate and the polar coordinate are the same.